Hello and welcome to Notebook. Let us start with a little game. Imagine it is a hot summer day. You come home from school in the unbearable heat. Running to your room, you turn on the fan for some respite. The cool, sweet breeze soothes you while you praise the great man who invented the electric fan. But why only him? You should also praise electricity. After all, there is no electric fan without electricity. So praise the marvel of electricity, the mystic force which drives everything from your toy car to massive trains. So, what is electricity? We have already seen it can serve a huge number of applications, tiny or massive. Through this video lesson, we aim to answer this question. Be sure that by the time you finish this lesson, all your friends will want you to explain it to them. In this lesson, we will cover the electric cell, current, electric switch, and the concepts of conductors and insulators. So, without any delays, let's jump directly into the first topic, the electric cell. The electric cell is something which we often refer to as a battery informally. This is actually incorrect, as unlike cells, batteries can be recharged. Cells are commonly used in electrical appliances like toys, clocks, and remotes. A cell is a device from which we obtain electricity. Have you ever observed a cell carefully? It is usually cylindrical with a small plus and minus sign on both ends, indicating the positive and negative terminals. The cell must be connected in the proper direction in an appliance, or else it won't function. An electric cell contains chemicals inside. When these chemicals react, they produce an electric current. Once the chemicals have reacted completely, the cell can no longer produce a current and is said to be empty or exhausted. Now we know where the current comes from. What about its use? Electric current is required by electric appliances. In our little game at the beginning, we mentioned the electric fan, which is an appliance. Let us consider one of the simplest electric appliances, a light bulb. An electric bulb consists of a round glass chamber inside which we have a thin wire called the filament. When current is passed through this bulb, the filament gets heated up. It becomes so hot that it starts to glow. This gives us a yellowish light. Electric bulbs get very hot. So do not touch a lighted bulb or one that has just been switched off. Now, we have a source of electricity, the cell. We also have an appliance which uses this electricity, which is our light bulb. So, we have a source and a destination. However, this is not sufficient to power up the light bulb. This is because apart from the source and the destination, you also need something else. If it wasn't so, then the bulb would light up if we just kept it near the cell. But obviously, that is not possible. So, what is this third component? Imagine you are standing on one bank of a river and wish to reach the other bank. You have your source and destination, but you do not know how to swim and there are no boats. How do you cross? There is no way you can cross the river without a bridge, just as there is no way you can drive to your destination without a road. You need a path that connects the source with the destination and allows you to travel along it. In electricity, we call such a path a conductor. Any medium that allows electric current to flow, like the bridge allows you to walk across, is called a conductor. The river, which does not let you reach your destination, is called an insulator. Air is a very good insulator of electricity. Thus, electricity cannot easily travel through air. Electric wires are meant to transmit electricity and made of good conductors like coil, copper, and aluminium, which allow electricity to flow easily and unobstructed. Now, we have a source, a destination, and a path. So, what are you waiting for? Connect the bulb to the cell with a piece of wire and bingo! Wait, what? The bulb is still not glowing? Here we come to another interesting property of electricity. It is very homesick. It can travel very far distances through wires and power numerous appliances. However, it will not do anything unless it has a path to return to its source. The cell current will light up the bulb only if it can then come back to the cell again. It's like you will cross the river only if you have another bridge which can take you back to your home. So let's grab another piece of wire and connect the other end of the cell to the bulb. Now our poor homesick current can also come back to its cell. He is happy and will light up the bulb brightly. Congratulations, you have successfully built an electric circuit. So, what is this electric circuit? A circuit is when a source of electricity is connected to an appliance through a complete path such that the current comes out from the positive terminal of the cell, passes through the conductor into the appliances, and then through another conductor to come back to the negative terminal of the source. This provides the current a complete path to follow. As discussed before, a current will flow only if the circuit is complete. If you detach one of the ends of the wires, the bulb stops glowing. There is no current flow in a broken circuit. Just like you cannot cross the river if the bridge is broken at any place. Now, let us learn a little bit about our remaining topic, switches. A switch is a device which allows us to join or break a circuit as and when we require. You may ask us, do we need to do so? Well, this is because if we let the circuit remain connected, we will waste electricity and our cell will get depleted very soon. Also, prolonged flow of electric current can create excessive heat in a circuit, which could damage the components. Just like in the previous example, we cannot let the boy repeatedly go and buy ice cream or else he will fall sick. So, we need a solution. What if we create a wonderful new drawbridge which can be disconnected if we want? Then, if we want to stop the boy from buying any more ice cream, we can just disconnect the bridge. This wonderful drawbridge is known as a switch. A switch can be used to break a circuit when not needed. We all have been scolded at least once for forgetting to switch off the fan. Switching off a circuit conserves electricity and protects the components of the circuit from overheating and damage. Let us add a simple switch to our little circuit. Connect the wires as shown to the two metal pins and add a safety pin. When the safety pin touches both clips, the circuit is closed and the bulb lights up. If the safety pin is removed, the circuit is broken and the bulb does not glow. With this, we come to the end of this video. Hope that we could make you understand the concept of electricity properly. We will meet you soon with another video where we will explain more such concepts with fun and examples. Until then, goodbye from Team Notebook.